Hello class, today I'm going to explain the cardiac cycle, which is basically everything that happens during one heartbeat. Let's cover some basic vocabulary first. So, very important to know that one heartbeat is one cardiac cycle, like I said. There are two main parts in the cycle. We have diastole and systole. I hope I pronounced that right, I don't really know. But diastole is when the heart is relaxed and is filling with blood, and systole is when the heart contracts and it pumps all the blood out. The atria are the top two chambers that receive the blood, and the ventricles are the bottom two chambers that push blood to the lungs and to the rest of the body. So, blood flows through the valves to keep it moving in one direction. The AV valves sit between the atria and the ventricles, and the semilunar valves are between the ventricles and the arteries. But this is like a simplified picture, so you can't really see them. Okay, so first phase. Let me drink some water real quick. The first phase is atrial relaxation and ventricular filling, which happens during early diastole. In this phase, both the atria and the ventricles are relaxed and the AV valves are open, and blood flows passively into the ventricles while the semilunar valves are closed. Then, next, the second phase is atrial contraction and ventricular filling. So, here the atria contracts and it gives the ventricles that final push of blood, which is referred to as the atrial kick because it contributes additional blood to the ventricles. And this phase also matches the P wave on an ECG, which represents atrial depolarization, and it triggers atrial contraction. The third phase is isovolumic contraction, which is the start of systole. The ventricles begin contracting, but all the valves are closed. The AV valve snaps shut here, and it creates the first heartbeat sound, which is called S1. The pressure builds in the ventricles even though the blood isn't coming in yet. And this phase is associated with the QRS complex, which represents ventricular depolarization. Next is ventricular ejection. Once the pressure in the ventricles is higher than the arteries, the semilunar valves open and blood is pumped out of the heart, and the AV valves stay closed to prevent backflow. And the last phase in the cardiac cycle is called isovolumic relaxation, which brings us back to early diastole. The ventricles are relaxing, the semilunar valves are closing, and this creates the second heartbeat sound, which is called S2. All of the valves are briefly closed while the pressure drops and the heart resets. And this phase lines up with the T wave on the ECG, which represents ventricular repolarization, and it lets the ventricles relax. So there are two primary heart sounds. We have S1 and S2. S1 is caused by the AV valves closing at the start of systole, and S2 is caused by the semilunar valves closing at the start of diastole. So, if we look at an ECG, we can notice patterns like bradycardia and tachycardia. Bradycardia is when the heart is beating slower than normal, usually under 60 beats per minute. So the waves, as you can see, it's more spread out because each heartbeat cycle is taking longer than normal. And tachycardia is the exact opposite. It means the heart is beating faster than normal, like over 100 beats per minute. So the waves look a lot closer because the cardiac cycle is happening faster. And it's important to know that even though the speed is changing between these conditions, the same cardiac cycle phases are happening like in each one. It's just stretched out on bradycardia and a lot faster on tachycardia. So, in summary, the cardiac cycle has 5 phases. I'm so sorry. The cardiac cycle has 5 phases that switch between filling and pumping blood. Diastole fills the heart. Systole, oh my gosh. Systole pumps blood out. ECG waves show the electrical activity behind each phase, and the heart sounds come from the closing of the valves. But everything works together to create one smooth heartbeat. Well, I mean, it's smooth if you're healthy, but I hope you're healthy. But yes. Thank you so much for watching. I hope this taught you something.